This conference will now be recorded.
Okay. Hello everyone. So today we will be learning about the adaptive models. So in the yesterday session I showed you this is the how the adaptive model looks like. So also I have showed you that we are getting the context not defined error. So we will understand why that error is coming and how to fix that error. So for an adaptive model, okay, for an adaptive model, you need to always set 5 mandatory parameters. Okay, so whenever you use adaptive model or even the prediction that is calling the adaptive model, you need to set 5 mandatory parameters. Without that, the adaptive model is going to throw error. So we will see what are those 5 mandatory parameters. So I will create a new strategy. So let us call it as predict credit card acceptance. Then I select the business issue as sales, group as credit cards, and then let us create this strategy on PEGA CRM dash data dash customer. Okay, so we will create this strategy on PEGA CRM dash data dash customer. So let us see what are those mandatory parameters and how does the adaptive model looks like. So first, let us import the propositions. Go to import proposition data. Okay, then what we will do is we will call set property method. Okay, so I just have this. Yeah, so go to enrichment and set property. Here within the proposition data, you can select import all propositions. Okay, import all propositions, and for the set property you need to set 5 mandatory parameters, right? Those are PY issue. Okay, second is PY group, and the third is PY name. Okay, see, that's the reason I'm asking you to remember these properties before you do that. Then the fourth one is PY channel, then the PY direction. Okay, PY issue, PY group, PY name, PY channel, and PY direction. So these are the 5 mandatory parameters which you need to set for adaptive model. Issue, that's a business issue. PY group, that's a business group. PY name, that is a proposition name, and the PY channel, that is a channel name, and the direction, which is inbound or outbound. So these three things we will be getting from the proposition data, that is for sure, right? So simply you can just say PY issue equal to PY issue, PY group equal to PY group, and PY name equal to PY name. Then PY channel equal to, you can set the value. For example, let me set it as email, assuming that I am going to send my offers through email. I am giving the channel equal to email. Similarly, since email is outbound channel, so yesterday I showed you, right, the list of inbound channels and the list of outbound channels. For inbound we have website, push notification, retail, IVR, all these things. For outbound we have email, SMS, and we have the call center. So these kind of things are there. So I am setting channel as email, then the direction as outbound. Now let us submit. Okay, so then set connect to this one. Okay, then what we will do, you just need to come here, select the adaptive model. Okay, then connect to the adaptive model, connect to the results. Now double click on the adaptive model component and you can select it. So your wish, if you want you can select prediction, within the here, you can drag and drop this, or you can directly import the adaptive model from decision analytics component. Under this category, we have adaptive model. So just remember that these are the 5 parameters that we need to set before you call adaptive model. PY issue, PY group, PY name, PY channel, PY direction. Direction will be either inbound or outbound. If you are setting a email or SMS, then it will be outbound. Let us say if you are setting a website, then it's going to be inbound. Okay, so depending on the channel that you set, you need to select the appropriate direction. So now here, this is my adaptive model, right, which I showed you yesterday, that it is auto generated. So I'm just selecting that, and under model context, you can see the identifier values when be set by the source components. These are the 5 identifier values: business issue, business group, name, direction, and channel. Now submit and run it. Now let us execute the strategy. So I will just click on the run button. Now the strategy has been executed, and I got all the 4 offers in the results along with the properties. Now we already know this, that you can see the propensity. So the propensity is the output of the adaptive model, which is mainly the output that we are expecting from the adaptive model, okay, which is nothing but the propensity. So yeah, so then along with that, we also have the evidence, so which we have learned yesterday. Okay, we have learned yesterday, and the propensity. Now let us go to the Dev Studio and check whether we are getting any error or whether it is executed successfully. So go to Intelligence, Prediction Studio, switch to the Dev Studio. Click on Configure, Decisioning Model Management. So this is where you can see the complete list of adaptive models and predictive models that have been executed. So now notice here, this adaptive model is coming correctly now. But see here, what it is saying, context not defined error. Here also context not defined error, the one that we have executed yesterday. But now you see, we are getting the email and outbound correctly, it is displaying, because yesterday we did not define the context correctly. Today we have defined the context correctly. So always remember, when we use adaptive model in the strategy, we need to set the 5 mandatory parameters. Otherwise it will display error like this. Okay, you need to set the 5 mandatory parameters. Now this is the adaptive model instance that we have executed. One thing that you need to remember is the adaptive model creates multiple instances for a unique combination of business issue, business group, proposition, and direction, and the channel. That means, let us say you have 4 propositions, then you will have 4 adaptive model instances. Okay, that means within these 5 mandatory parameters, even if one parameter is changing also, a new adaptive model instance will be created. So that's the reason you can notice that. So this is one line. So then you can see here one more is there, right? Second adaptive model instance. Similarly, here third adaptive model instance is there, and fourth adaptive model instance. Since there are 4 propositions, I have 4 adaptive model instances created. Okay, I have 4 adaptive model instances created. Each and every instance will provide the analysis for that particular proposition. Okay, if you have 10 propositions, you will have 10 adaptive model instances. So that means out of all these 5, even if one parameter changes also, a new adaptive model instance will be created for every unique combination of these 5 parameters, that is issue, group, proposition, direction, and channel. Now that's what the adaptive model will do. That means multiple instances will be there. The rule is only one, but the instances will be multiple. If you have 5, you will have 5 instances. If you have 10, you will have 10 instances. Now let us go to the adaptive model analysis and see what we can understand by this particular screen. So in this particular screen, you can see the adaptive model is displaying the graph. So basically this particular graph indicates that there are some responses for the adaptive model for the propositions. So you are seeing some bubbles, right? Each and every bubble corresponds to one particular proposition. Let us say if you are seeing 10 bubbles, that means there are 10 propositions that got responses. So whichever the offers or propositions that got responses from the customers, those offers will be displayed as bubbles. Okay, each and every bubble corresponds to a proposition. Right now you can see there are 4 bubbles are there. That means there are responses received for 4 propositions. Okay, the larger the bubble size, the more the number of responses received. Okay, so if you just notice, out of all these 4 bubbles, this bubble is having large size. That means this particular bubble is very big, right? It is very big. That means there are more responses received for this particular bubble. You can see this bubble is very small. That means there are very less number of responses received for this bubble. Okay, the bigger the size of the bubble, the more the number of responses received. The smaller the size, the less the number of responses received. So when you keep your mouse on the particular bubble, you will be able to see the details about that particular proposition. Like you can see, this is a premier rewards card, and this is a rewards plus card, this is a rewards card, and this is a standard card. Okay, now here we can see the AUC values also, right? AUC values. So I'll just tell you, like, see the statistics that are present at the end of this particular hover text you are getting, right? So there are 3.11k, that last one, that 3.11k is the number of responses received on this particular rewards premier rewards card proposition. Similarly, let us keep here, you can see the, when you keep the mouse here, for rewards card there are 484 responses received. Just check the last value that is there, which is 484. That is nothing but the number of responses received, and for this is 2.85k, and here it is 2.21k. That is the reason this bubble is very big, and then it is this one, and then this one, and finally this one, because this is having very less number of responses, that is only 484. Okay, so that is how you need to understand the graph that is present here. Now there are 2 other components that are there. That means, for example, if you just see here, success rate. Success rate is the percentage, it's a total, it is nothing but the total number of positive responses divided by total number of responses into 100, or you can say without 100 also. So the total number of positive responses divided by total number of responses. For example, let us say that there are 1000 responses made by my customers. Out of 1000 responses, 700 responses are positive. That means 700 responses 700 responses are like accepted. So now your success rate will be 70%, right? So if you're having 100 responses, you have received 40 positive responses, your success rate will be 40%. So that is how the success rate will be calculated. Within this particular adaptive model, there are 4 instances here, and you can see that out of all this, the Premier Rewards card is having 38.49% success rate. That means out of 3,110 responses, 38% responses are positive. Okay, out of all this, 38% are positive. More than 60% are negative. Okay, more than 60% responses are negative. That is the meaning of this. Okay, and the performance is nothing but the area under curve. Area under curve is nothing but it will just indicate the performance of a particular proposition, which is calculated by using machine learning. There is no specific formula. So the range for AUC will be from 50 to 100. 50 being the lowest value, 100 being the highest value. By default, every single proposition will have 50. We have seen it yesterday, right? Model performance equal to 0.5. Model performance equal to 0.5. That's nothing but that particular proposition is having 50% performance, which is the default performance. So this performance will increase along with the success rate and also the propensity. Okay, this performance will increase. Yeah.
So what is the significance of performance? I mean, let's say if you have like 85% performance, like what does that actually mean?
So it just means that this offer is performing better. So this offer is more liked by the customers. That's it. So
Is
also
it
the yeah.
is it that, or is it like the machine learning is predicting like 85%? I mean, better for that one.
This is not a prediction. This is just performance, which is nothing but how better this offer is performing.
Oh, okay. Mm,
So the
okay.
prediction.
So how do you differentiate between that success rate and then this performance?
Yeah, that's what I'm saying. The success rate and performance generally go together. Okay, generally they go together, and also it also depends on the propensity. This performance will be calculated based on success rate and also the propensity of this particular proposition. Depending on these two, this performance will be there. You should look for the offers mainly with propensity and also the performance. Both of them you need to consider, and this output will be from adaptive model. Okay, this is the output that is generated from adaptive model. Okay, so this is a machine learning calculation which we don't have the formula. It is done by the machine learning calculations, and it generally gets calculated based on the propensity and based on the success rate. So the higher your propensity, the higher your success rate, then automatically your performance will also be higher. Okay, yeah. So along with this, you can also notice the model report for each and every adaptive model instance. So as I told you, if you have 4 adaptive model instances, then if you have 4 propositions, you will have 4 adaptive model instances, right? So that means I have 4 propositions here. That means the unique combination of issue, group, proposition, direction, channel. Now when you open the model report, you will be able to see the information about that particular model instance. You will be able to see the information about that particular model instance. That means in order to achieve this much performance, in order to achieve this much success rate, what are the contributing predictors? What are the contributing predictors, and which predictor is more performance and which predictor is less performance. Okay, so that is the thing. So this particular thing here, right, whichever is there, it is like average also. You can say it's like average of all the predictors that are present here. So for individual predictors, there will be a performance, and basically the average will be your performance AUC curve. Okay, you got it right. So just notice the performance here, the 58, right? And you can see the performance values below, they are 50. Okay, and also let us say if you check for the performance for other reports, like let us say I check this one, and you can see what is the performance average, like that it will check, and also the success rate. So there is no specific formula like how it is getting derived, but only thing that you need to remember right now is the range for that will be from 50 to 100. Higher the performance, higher the offer that is performing. That's what you need to consider. Now coming to the model report, within the model report for each and every proposition, we will be able to see what are the list of top performing predictors. Okay, what are the list of top performing predictors? Along with that, which predictor is having higher performance? Okay, which predictor is having the higher performance? So based on the analysis that the adaptive model has done, the adaptive model has given the output that average spent is having more performance. Basically what it means in our understanding is the average spent, the difference in the average spent of the customer is impacting the customer behavior. In that case, the performance of that particular predictor will be high. This is called as correlation. Okay, this is called as correlation. The difference in the average spent of multiple customers will impact the customer's behavior, will impact the customer's response. So this you call it as correlation, and adaptive model works and derives the propensity based on this correlation. If there is no interaction history data, even if it is there also, it will do correlation on the data that is present in the customer data. Okay, so correlation means, for example, let us say there is a customer A. The customer A is having average spend of $100. Customer B is there, he is having average spend of $500. Now let us say A is accepting the offer, B is rejecting the offer. Now based on the difference, the adaptive model came to know, because the average spend of A is generally within 100 range, average spend of B is having like 500 range. So that means there is a difference in the data that is present in both the customers. Then the correlation will be done based on this analysis, and it will increase the performance of that. Because clearly, if the adaptive model sees the difference between the data is impacting the customer's action, then those predictors will be ranked higher. Let us say if you just see the gender is having only 50.81. Okay, the gender is having only 50.81. That means, let us say male customers are also behaving same, female customers are also behaving same. That means there is no impact. Okay, like male customers are also accepting the offer, female customers are also accepting the offer, then the performance for that will be low, which is like 50. Okay, so like this, depending on the discrepancies that they see, that the adaptive model sees with relation to the customer's response, then that predictor will be having a higher performance. You are able to understand or not? Is it understood or confusing? Hello. Is it understood or confusing?
No, it's not.
Clear, right? So now there is a range also. So how does the adaptive model do the correlation now? Okay, how does the adaptive model do the correlation? Let us take age. Okay, let us take age. So what I was telling is, let us say there is a customer with age 15. Okay, so what I was saying is, okay, so let us take a customer with age 20. Okay, so there is a customer with age 20 and there is a customer with age, let us say 80. So this customer has accepted, okay, and this customer has rejected. So this is how the adaptive model will correlate within the data, and it will check which particular predictor is high performance and which particular predictor is low performance. If it is high performance, that means this particular data is impacting the customer's decision. Now internally it will perform an operation that is called binning. Okay, so what is meant by binning? Binning means creating partitions with equal intervals. Okay, binning means creating partitions with equal intervals. So what does it do is here, so let us take that for age, the minimum age customer who has responded is 25. The maximum age customer who has responded to the offers is 60. Okay, so this is the minimum age customer who has responded to the offer, either it is positive or negative, either it is accepted or rejected. Similarly, the maximum age customer who has responded is 60. Within this particular range, the adaptive model will create partitions within equal intervals like this. For example, 25 to 30, 30 to 35, 35 to 40, 40 to 45. If you notice, all the partitions are having equal intervals of 5. Okay, they are having equal intervals of 5. This process we call it as binning. Okay, we call it as binning, and this we call it as bins. Okay, this we call it as bins. So how many bins we have here? 2, 3, 4, 5, 6, 7. 7 bins we are having here, right? 7 bins we are having. Binning is creating partitions with equal intervals, and we are able to have 7 bins with the interval of 5. Now that is what you can see it here. Let us check age. If you check age, the minimum age customer who has responded is 19, and the maximum age customer who has responded is 80. So between these two values, the adaptive model has created 12 bins. See, you can create the same bins with like this also, right? Like you can also create 25 to 27, 27 to 29. This is also bins only with an interval of 2. Okay, if you just create partitions with equal intervals, that is nothing but called as binning. And within this particular age group, with the minimum age as 19 who has responded and maximum age who has responded is 80, the adaptive model created 12 bins. Okay, so this is the responded customers, not the customers that is present in the table, only the ones that who has responded to the propositions. Now then what the adaptive model does is it is going to allocate customers to each and every bin. Let us say within 25 to 30 there are 3 customers, and within 30 to 35 there are 5, and let us say within 45 to 50 there are 2 customers. Like this, whatever the customers that who has responded to the offers, based on the binning that it has done, those customers will be categorized into each and every bin. These customers which are present in the bins, we call them as cases. Okay, that means here we have 3 cases, here we have 5 cases, and here we have 2 cases. So the customers who are present in these bins, they are called as cases. Okay, now the advantage of having this information is it can more accurately predict which particular age group is responding positively. Let us say it came to know like 25 to 30 accepted and 30 to 35 accepted, and let us say 35 to 40 accepted, and all the remaining age groups they have rejected. Okay, all the remaining age groups rejected. So when the adaptive model has created bins like this, it can much better predict the exact age group where customers are accepting. Okay, it can predict much better the age group where the customers are accepting. So this way the adaptive model will again predict, okay, this particular age groups are accepting the offers, so it will try to send the offers to this particular age group, and it will recommend this particular age group to be sent. The more granular you make the binning, the more accurately the adaptive model can provide the propensities and also the particular predictor which is having more performance. Okay, it can clearly understand now this particular age groups are accepting and this particular age groups are rejecting, because there is a significant difference when the correlation has been performed. So then it will rank this particular age with performance higher. Okay, it will give a higher performance for this particular age group. So that is how internally the binning process happens, where it will take the minimum age customer, maximum age customer who has responded. That range will be divided into bins, which is the partitions with equal intervals. These equal intervals will have the customers, which we call them as cases. Now it is able, if it is able to find out like a difference between the age groups and the customer behavior, then it is going to give a better performance for that. Let us say here some people have accepted, here some people have accepted, here some people have accepted, then it will not give a good performance for that particular predictor. Okay, so because it's not able to correlate and predict that this age group is having more acceptance, because in all the age groups some people accepted and some people rejected, which is very hard for adaptive model to understand whether this particular predictor is a good predictor or a bad predictor. So that is how the adaptive model internally understands these predictors and provide you the report. Now coming back to the model, So if you go to the settings, this is where you can actually define the several values. Like you can see here, this is the evidence. Okay, this is the evidence. If you don't set the model evidence in the strategy, you can set this particular evidence here. Update the model after every 1 responses. Let us say if you give 10 responses, it will wait till 10 responses. After 10 responses only, it will update the model. That means it will recalculate the performance, it will recalculate the propensity, all these things. So that is the option that you specify here, which is nothing but called as model evidence. Then this is where you can specify the granularity settings. As I told you, data analysis binning, grouping, granularity. So what we are doing here, we are grouping the bins, right? 25 to 30, 30 to 35, 35 to 40, like this. So we are creating the bins and we are grouping the customers. Like these 3 customers belong to this bin, these 3 cases. So grouping granularity means how granular you want to create your adaptive model, right? That means what? That means whether you want to create more and more bins or whether you want to create very less bins, right? So if you just see here, I can create a bin with the partition with the interval of 5. I can also create like this also, like 25 to 35, 35 to 45. That means this particular granularity is very less, but here the granularity is good. Okay, here the granularity is less, here the granularity is good. But when you do it like this, adaptive model will not have the accurate age group where the customers are behaving differently. But if you create more and more bins, then the adaptive model can clearly understand which age group is more accepting and which age group is less accepting or rejecting. So, but when you increase the number of bins, then there is a chance that the performance will also slow down. So whenever you see the predictors with very less performance, then only you need to modify this granularity settings. For example, in my model reports, I am able to see some predictors are having 80% also, right? For example, here in this particular model report and here in this model report, it looks like there are some predictors which are having 80%. So here it is 76%, which is also good. At least 70% above or 65% above is a good predictor. Okay, so that is good predictors. If you are seeing most of your predictors are having like 55, 56, less than 60. Okay, if they are having like less than 60, which means the adaptive model is not able to understand which predictor is potential predictor. That means because of difference in the age only, customers are accepting. So it is not able to identify that correlation. So at that time, you can modify the settings. You can increase the granularity. Let us say you can keep it like 0.40 or 0.30 like that. When you increase this value, we need to decrease this value. What is this? This is nothing but grouping minimum cases. Grouping minimum cases means what? Grouping minimum cases means, I told you, right, for every single bin, the adaptive model will assign cases to that particular bin. So that means grouping minimum cases means within each and every group, how many minimum cases should be there. So what does this setting is? Within each and every group, there should be at least 5% of customers. Okay, 0.05 means 5% of customers should be grouped into one bin. At least minimum 5% of customers should be there in each and every bin. That is the meaning of that. But whenever you increase the granularity, let us say you are creating more granular bins like 25 to 26 like that, right? Very granular,
So,
just
quick
within one.
question.
Yeah.
Are So in the real-time projects, who gives these values? I mean, would there be any data scientists on the project who would look into
No,
this one and give
there's
these
no data
values, or
scientist. There will not be any data scientist. You should only do all these things. In any
okay,
project, data scientist will not be there. By default, these are the OOTB values. As I told you, right? You check the model report. Within the model report, if you don't see the predictors with like 75, 80, above that, like above 70 at least, if you don't see the predictors above 70, then your adaptive model is performing poor. At that time, you can modify the settings. Okay,
okay,
only then you will modify the settings, otherwise you don't modify.
okay,
Yeah. So now in my case, I have seen a model report that is having only 50s. There is not even 65 or 60 above performance is there. That means the adaptive model is not able to find the appropriate predictor, which is actually the potential predictor for my customer's response. So at that time, I will come here and I will create more granular groups. Like I can keep it like 35 or 40% here. When I increase this value, next time when the adaptive model executes, the granularity will be more. That means the number of bins that you see in the report, it will be more if you increase this value. So that is how you can confirm whether this change has increased the bins or decreased the bins. As you increase the bins, then you will definitely see some increase in the performance of the predictor also. Along with that, you should also decrease this value, because when I say 26 to 27, instead of 3 customers, I might only have one case, right? I might only have one case can be there, because the age group is small. The age group difference is small. So I cannot accommodate more number of cases, because this is the minimum percentage. So if you increase this value, you should always decrease this value. Okay. So you need to remember that both of them should be modified. Next, we have one more configuration here, which is activate the predictors with a performance above 0.52. That means what it does is adaptive model will automatically deactivate the predictors below 52% performance. So as I told you, the minimum will be 0.50. Okay, you cannot give below 50. Okay, you cannot give below 0.50. Okay, it will not work. It might not show you any statistics. Okay, so always give from 0.50 to 1. If it is below 0.52, we are just saying to inactive those predictors. That is the reason. If you just come to the model report, let us say I open this and you scroll down, you can see the, yeah, here everything is above 52. Okay, let's say I go to another report. Let's say I open the first one, and this particular offer is, you can see, right, all these are 50, 50.7, 51, all of, and all of them are inactive, right? All of them are inactive. Whichever is there below 52, they are automatically set to inactive, because the adaptive model will not take its time to analyze this particular predictor. It will not waste its time to try to understand this particular predictor's correlation. So it is just waste of time, and you don't spend any time on this. So automatically it will inactivate that. You can increase your adaptive models analysis power by increasing that value. If you are seeing good predictor performances, you can try to adjust this value, and you can keep it like 0.55 or 0.60 like that, so that it will only work on analyzing the predictors which are having above 60 performance. So this is the value where you can set to deactivate the predictors which don't have good performance value. Okay, so this is the particular option that you can do. So next time when the adaptive model runs, automatically whichever is below 60, it will set as inactive, which you can see the status here. Okay, so that is this particular option that you see here. See, again, you just do this only when you don't get expected results. within the model report when you don't get expected predictors with good performance. Okay, so that's what you need to just understand, because these predictors will automatically help the adaptive model to generate the better propensity and try to understand which offers are good and which offers are bad. Okay, so it will in turn help in that way. And also the success rate also, that means which offer is more successful, which offer is less successful. Okay, so these two are very much useful, because next time the adaptive model generates the offers, it will clearly understand that this particular premier rewards card is going to be having more propensity. Okay, because out of all of them, this particular offer is having good success rate. I mean, it's not good, but at least out of all the four, this is the higher one. So the propensity for this one will be higher compared to the remaining three. Okay, because more people have accepted this when compared to the above three. That's the reason the propensity will be high for this offer. So this is how the adaptive model configuration will be there, and that's how you need to understand this. Okay, so probably, yeah, that should be enough here. Okay, should be enough here. And you will also see the interaction history fields. So one more thing is, as I told you, the adaptive models are self-learning models. Self-learning models means you don't need to provide any historical responses, like these are the customer responses. This customer ID has accepted this offer. This customer ID has rejected this offer. This kind of information you don't need to provide to that, right? Automatically it will learn based on the predictors and also based on the interaction history data. Now, how do I know whether this adaptive model is learning or from the interaction history or not? As the data that's come to the interaction history, then the adaptive model will automatically learn. Okay, initially, even if the data is not there, it can provide you the propensity. As the data gets available in the interaction history, the adaptive model will retrieve the data from the interaction history by using the adaptive decision manager, that is the ADM service, which is responsible for training the adaptive model. So all you need to do is you need to just come to this particular predictors tab within the IH summaries, make sure that this is enabled. Okay, you can also disable this. That means you don't want to listen from the interaction history. See, now I have disabled it. Okay, if you want to learn from interaction history, you will enable it. Interaction history summaries means it is like retrieving some custom information from the interaction history. Okay, for example, within from the interaction history, I want to get last 10 days customers interactions. Then you need to create the interaction history summary. Let us say I want to retrieve last 2 days data, last 1 hour data, okay, or last 1 year data. Then you need to create one interaction history summary. The interaction history summary will allow you to retrieve the information from interaction history for some custom time period. Okay, so we have a separate topic for that. At that time we'll see how to create and all that. But only thing that you need to make sure is just check whether this IH summaries are enabled or not. If it is enabled, that means it is learning from interaction history. If it is disabled, it will not learn. That's it. So this is the only thing, and it will automatically learn if you just keep it enabled. That's what you need to make sure whether adaptive model is going to learn from the interaction history or not. Yeah, so that's it. So just go through this tab, try to understand this graph, go through the video again if you did not understand. Okay, just try to understand this graph and how the bubbles are there, what is the purpose of this bubble, what is the performance, what is the success rate, what is the purpose of binning, how to modify these settings, all these things. Okay, so any questions on this topic? So we will see a POC at the later sessions where we can test the customer response manually, and we will send it to the adaptive model. Okay, we will send it to the adaptive model and we will try to capture the customer response. That we will see at the later sessions. But concept wise, everything should be clear. Okay, what is this AUC, what is the success rate, what are these different values that are there, what is binning, what is correlation. Okay, so this should be understood. Any questions?
So the POC we will be creating, or just you will be showing us?
I will be showing you the POC. I will be giving you the assignment. So you can have an assignment which you can practice. The POC I will only demo it and show you. But similar assignment I will give to you so that you can practice it. But concept wise, configuration wise, are you able to understand what is present where? Yes, no.
Those things I'm able to understand, but since this is new, it's taking time. This concept, those terms, everything.
Yeah, just please go through one times, two times, or three times. Okay, you need to learn adaptive models and predictive models. They are important in decisioning. Okay, so how to configure, how to use it in the strategy, what are the mandatory parameters that you need to set, all these things you need to know. Okay, like you can see these five are the mandatory parameters. Okay, any other questions? Clear? Okay, so if no questions, right, yeah, I'm just fine. So let us connect tomorrow. Okay, so we'll see the next topic. But meanwhile, please go through the video, learn again and again. Just try to understand every single tab that is there, whatever I told you. Okay, like this granularity, what is binning, what is the predictor selection, how to deactivate the predictors, all these things. Okay, that should be enough. All right then, see you tomorrow.